Good morning, good afternoon, good evening. Thanks for joining us for this very first session of Devtoberfest. So happy to be here kicking things off this morning with this introduction to ABAP objects, object-oriented patterns. One second. Introduction to ABAP objects. Sorry about that. I was getting some audio echo there. Just had to take care of that. Just wanted to welcome everybody. Before we jump into the content of the object-oriented topic of this morning's session, I wanted to do a quick overview of what you can expect from Devtoberfest. Just a little reminder here. First of all, if you come to the SAP community and you go to the groups and you say all groups, you'll be able to navigate to the Devtoberfest group. This is where all the content about Devtoberfest will be available. And if you haven't already, be sure to join this group. Now, I don't see the join button because I've already joined the group, but joining the group is what's going to enter you into the Devtoberfest contest. Now, the other important thing to keep in mind, particularly if you're interested in the contest, is we have the fun game board, and you can track your progress in the contest, how many points you've accumulated. But to run this game board, you have to put your SAP community ID onto the end of the URL. Now, your SAP community ID is not necessarily the same ID that you would see here in the community groups, but instead, when you come to the community home, you can click your little icon in the upper corner and click on manage my account. That will take you to this people.sap.com URL. And this is where you can find your community ID. It's right here in the header, or it's listed here under username, or it's probably here in the URL itself. That's the ID that you're going to want to take and put onto the end of the URL of the game board. And that will show you how you're progressing in the contest. Now, do keep in mind, if you have just joined the Devtoberfest community, registered for the event, there's a batch load to load these records into, to assign the badges and give you your initial registration points. There can be a little delay in showing up in the game board, but don't worry, all your points are still being accumulated. You'll see them retroactively once your registration is processed, and you can see them in the game board. And the last little bit of Devtoberfest general information that I'll share with you here is if you're attending events like the session right now, many of these will grant you points as well. For instance, if we would just come here to the events board and we'd look at Devtoberfest, you can see introduction to ABAP, object-oriented patterns, which is going on right now. And actually, if I either look here in the comments of this one, I put a link to a tutorial, but you'll also see it in the description on YouTube. So right here where everyone's watching it on YouTube, in the description, there's a link to a contest where it says contest validation for this session. And if you click that, that takes you to a tutorial in our developer center, developers.sap.com. And all you have to do if you want to get points for attending the session is answer one or a few simple questions about the session. And many of the educational sessions that will take place during Devtoberfest will have these little tutorials that will grant you little points towards the contest. So if you're watching live or watching at any point during the month of October, you can then come here to the tutorials and earn a little bit of points for having attended the session. So that's all just a little bit of reminders about Devtoberfest. And now let's go ahead and dive into the content. Let's go close that. Let's bring up my ABAP development tools for clips. Now, I'm going in today's session, we're going to talk about general ABAP object-oriented concepts, but I did all the development in a ABAP steampunk system, so on the SAP Business Technology platform. So if you have access to a free trial or free tier instance of SAP Business Technology platform, you've got a place that you could go to recreate any of the samples that I'm going to show you here today. I did use a sprinkling of newer syntax, although I don't think there's anything super new in here. I kind of stuck with the introductory basics. So these are also things that you absolutely could do on most any recent release of on-premise ABAP as well. I want to go through a series of classes that I've prepared to show a couple of different patterns. Now, there's a lot of different object-oriented patterns, and the topic of patterns can mean different things to different people. There's some agreed upon general patterns when it comes to object-oriented programming in various different languages. You'll see lots of examples online, done in C++ or done in Java. As I looked through those patterns, and last week as I was preparing for the session, I looked through a lot of those different patterns. And it was interesting because not all of them really apply to the ABAP world, I would say. And part of that has to do with the session lifetime in ABAP. We don't have necessarily, other than batch programs, we don't have the long running applications similar to what you might have in some other programming languages, where session state in an ABAP class lasts for the dialogue step or the program execution. And when it comes to sharing data or communication between multiple objects, we have a little less of that in the ABAP environment. And actually, you get into the specialized kind of constructs like shared memory objects when you get into some of those patterns. And I wanted to instead focus on the more general patterns that are probably more applicable to everyday ABAP programming, and not some of those specialized edge cases like shared memory objects, cross-application server, things like that. But let's begin with just a basic introduction to object-oriented in the ABAP world. Just maybe a refresher for some of you, get some of the terminology down, and then we'll go into some more advanced examples here. So first of all, this is very basic class that I've created here. Went with the default settings, which is a public definition, created publicly. So nothing unusual about the way that I instantiate this class so far. We'll get into some other examples there. We see I have declared a type in the public section, and I have declared an internal table to be an attribute of this class, the sample internal table. Now, what's perhaps interesting here is I've declared it with class data. That makes this a static attribute, which means the data in this internal table lives outside the instance of this particular class. So if I instantiate more than one instance of this class, it will still share a single instance of this internal table between those two instances of that class. Now, I did this on purpose because this difference between instance methods and static methods and static and instance data or attributes becomes pretty important to a lot of the different patterns in object-oriented programming. And we're going to see this in use here right away. Then I've created two different methods. In this case, both instance methods. This first one takes a importing parameter of type string and then returns a string as well. Second method just returns an internal table. And as it turns out, what we're going to do is we're going to return the value of this sample internal table, this attribute in our class. Now it's public, so we can access it directly. We can also wrap it in a method and return it. And I did this on purpose as well, to kind of set up what some of the patterns do later. If our attributes are not public, usually we'll use methods to read and write them. And I wanted to show you both those different approaches here in the beginning. Now, the implementation of the class, there's not a whole lot to this implementation. The first method, we're going to take whatever the importing value is, and we're going to concatenate it together and just add on a little extra here, say plus some new stuff, just to know that we've manipulated it a little bit, and then we're going to export it out. So we're going to send it back out as the returning parameter. But we're also going to take whatever is in that exporting parameter, and we're going to write it to our internal table. So every time someone calls this the my first method, we're going to write a record into this internal table. And that's going to allow us, I'm going to demonstrate here in a second when I run it, we're going to be able to see how two different instances of this class are both writing into the same internal table. The second method, as I said, is just going to return the internal table back out. So we're just going to copy it into the returning parameter of the method call. And you see here that because it is a static attribute, I use class data to define it, I can access it with the full name of the class. This is what, when you use the class name and the equals with a greater than sign, you're accessing it, the static attributes or static methods of a class, as opposed to if I had, well, I wouldn't be able to do the class name and then a minus and a greater than. That would be an instance that would be accessing an instance method or attribute of the class, which we'll see here in a second in my class tester. Let's go ahead and pull up the test class. Let's see if I can just get these pretty nicely side by side. A little more room there. What I've done here is I've just created a second class so that I can test this first class. I am using the interface IFOO ADT class run. This is what we can use to output to the console in the ABAP development tools. It's a much more common way to test your classes, at least interactively test your classes, particularly once you move to Steampunk or ABAP on BTP or as part of S/4HANA Cloud, because we don't have any SAP GUI support. So I can't write a regular program, list processing, or write statements. So instead, you add this interface to your class and then implement the single method of that interface, which is this class run main. And when you execute this class, you have an out object and you use the write method, and that's going to output to the console. in the ABAP development tools. So very similar to issuing a write statement in classic did pro applications that would output to the SAP GUI. But now we have a SAP GUI option here, a non-SAP GUI option to run our applications. So let's see what we're going to do here. So what I want to do first is I'm just writing out some headers so that we can kind of trace what we're doing. But we're going to start by outputting that static attribute, the sample internal table. And notice I'm able to access it, even though I haven't created an instance of that class yet. That's what static attributes do. They can be accessed without even having an instance of the class. So give it the full class name, the equals, and the greater than sign, and I'm accessing the static attribute. Now I'm going to create an instance of the class. So that's what I'm doing here. New class instance equals new and the name of the class. So that calls the constructor. I didn't actually implement a constructor in my class. That's fine. You don't have to implement a constructor. You get an implicit one built in the ABAP language that will create an instance of the class. I'm able to call my first method. That's going to send in first call, which should output, the return, the export with the manipulated first call. But then I'm also then calling my second method, which is going to return the same static attribute internal table. And we should see that one record that we put in there, right? Then we're going to call the first method again, and we're going to check the internal table again. We should see our second record. Then I'm going to clear the instance of the class, so the instance will not exist anymore. And I'm going to output that internal table again. And then I'm going to create a brand new instance of the class. I'm going to write into it again, and then I'm going to output the table. And what you will see here is that this internal table lives even though we clear the class, it continues to live. We create a new instance of the class, it continues to live. And when we add records to it, we'll be adding it alongside the records that already exist in that internal table. So let's go ahead and run this. And exactly what we see here, we start off, the table is emptied to begin with. And then we call it the first time, and there's our first record in the table. Then we call it the second time. We get our second record back, and we see that the table now has 2 records in it, exactly as we would expect. But then we clear the instance, but we're still able to access that internal table, even though we cleared the instance, and it still has our 2 records in it. There we are. And then we create a brand new instance of the class new instance, and we write a 3rd record into it, and we read the internal table. And even though it's a brand new instance of the class, it still has the first 2 records in it as well. So we have 3 records in total, even though we have a brand new instance of the class. So static attributes, instance attributes allows us to choose whether we want the data lifetime to only live with the instance of the class, or whether we want it to live beyond that. Now, if we just want to prove here to you that that instance of the class is really gone, what I'll do is I'll come here. Let's clear the log. I've cleared the instance of the class. Now I'm going to try to access it, even though I cleared it. So let's just change that. And now run it again. And it short dumps. So the instance is really destroyed. It won't let us access it, right? But the internal table that we declared still lives on. Now, that's a very powerful concept when used properly, but look what it lets me do from my calling program is because that class data is exposed directly as a public attribute, then any calling program can manipulate it as well. Because I can come here, let me just comment out these two lines, and I can directly append a line to that internal table in my static class before I've even created an instance of it. And I'm going to sneak another record in there, sneaky stuff I injected. I'm going to activate that. And now let's run. And now you see my sneaky stuff I injected is in the internal table as well. And this is what you have to be really careful about when we start getting into usage patterns is we have to think about, do we really want to expose that in this way? We want all the calling programs to be able to manipulate an internal table without any logic in my class being wrapped around it, without being notified that someone from the outside is manipulating the table. Maybe we do. Maybe that's okay. But in many cases, you probably don't want that level of access, which is where we start getting some patterns to control access to parts of our class. Maybe instead of making that a public static attribute, we want the calling programs to have to be able to pass through a method to access it, like we did by calling the second method. But then, that's an instance method. Maybe that gives us a little bit more control over what we're doing here. So before we even get into talking about different patterns, it's important to understand these concepts, because many of the patterns rely on either inheritance or visibility, core concepts of object-oriented programming in general. Now, there's a good question here in the chat. What is the life cycle of that static instance? It's only for the lifetime of this class, remember. And the class is only going to live during the session run of the program that it's in. So if I were to open, another session here and run it in a separate console instance, I would not have access to that same static attribute. It does not live outside my user session. So it cannot be used, unlike some programming languages and environments, cannot be used to share data, say, between different user sessions. For that, we have shared memory objects in the ABAP and in the ABAP runtime. That's a specialized use case, a different type of class, actually lives outside the user session and in the application user role space instead of the user session. But the static attributes that we're dealing with here are inside my user session. Yeah, okay. Is this internal table data available if we were creating the class data instance in a different session? No. Okay, so similar variations on the same question that I think we've just answered here would not cross over user sessions. So it's mainly something you would think about within the lifetime here. Now, I could change this real quick here. I could change this to a regular data attribute, and then let's just change that. And if it's no longer class data, if it's now just an instance attribute, well, the first thing that's going to happen is I'm not going to be able to access it before I create an instance of the table. If I try to run this now, syntax error, right? Because I'm trying to access it as a static attribute, and it's no longer exposed as a static attribute. So if I take out those couple of lines, and another spot where I do that. That should fix it all. And now if I run this, we're going to get very different results, right? Because I call the first one. Oh, what did I do wrong? Let's try that again. There we are. That's what I expected to see. So what I have here is now on the first instance of the class, I'm able to put both records in the table. But now, as you might expect, once I clear the instance of the class and I create a new instance, now that data, that internal table is tied to the instance of the class. So it's cleared up when I clear the instance of the class. And now when I write a new record in it, that's the only record that's in the internal table at that point. The internal table is tied to the lifetime of the class itself. All right. That's a good first example. Now let's go just a little deeper real quickly here on static versus instance, because that first example was how we can do it with an attribute. But let's look at two different classes that basically implement the same logic, but do it one as a static class and one as an instance class. So what we have here on the left is we have a class that is going to get all the flight details from the flight demo database, and then a method that is going to calculate the flight price. Given a particular flight, you have to input which flight you're looking for, and then we'll export out the price. Now, in this case, we have two class methods, which means these are static methods. They can be accessed without creating an instance of this class, but that also means that we're not carrying over any data from one call to another. So if we look at the get flight details, we're selecting a record from the database. When we go to calculate the price, we can't carry over any data from the flight details. We have to select the data again from the database, and then we can calculate the price and return it. Now, this is much more like an ABAP function module, in that when you have two functions in a function group, they're often completely self-contained like this. They have a set of input parameters, and you don't carry many, if any, data over between the function calls. So this is sort of anti-pattern here in many cases, in that you're trying to create classes that function very much like maybe what you're used to with function modules. The same implementation, but done now using an instance approach, where we have a constructor. And when we create the instance of the class, we go ahead and we pass in which flight that we're interested in, the keys of that flight. And by passing them into the constructor, we're able to, in that constructor, go ahead and do our select and preload all the details about that particular flight. And store them in an attribute so that they're available for future methods. So then when we have our get flight details or our calculate flight price, the methods themselves don't need to repeat the importing parameters in each method. We have it as part of the instantiation of the class itself. So each instance of this class matches a single record in the database. So we're really using the class to represent a record in the database, and then all the actions that you can perform on that record are methods of the class. So it's really acting as a facade for the single record in the database. So we're starting to see a pattern emerge here where we can use object-oriented constructs and ABAP classes to represent something else, in this case, a single record in the database, and encapsulate all our access to that record in the database. It simplifies and keeps us from having to repeat the importing parameters. It also means that instead of multiple selects against the database to read redundant data, we've prefetched that data during the constructor. And then each time we call the method, we don't have to go back to the database. We can access the data that we have stored in the instance of the class. All right, let's look at my tester now for this particular example. And what it's going to do is, you can see here, if I'm accessing this using the static, I call the calculate flight price. I have to know my keys, two different flights I want to check for, two different sets of keys. And then the same thing, I have to repeat it when I want to get all the flight details. But when I have an instance, I create an instance of the class, I pass it the keys, and then that instance, I can call the flight price, the calculate, I can calculate the flight price and get flight details directly off that instance. And in this case, I'm able to create multiple instances and then call the different methods for that particular instance. It produces cleaner, more readable code from a consumption standpoint, and is now operating in a better usage of object-oriented, as opposed to just recreating a function module as a class. We're truly using the class as a facade pattern to represent the underlying database record or an instance of a flight in this case, which is done via a single record in the database. And I'll go ahead and run this one. This is not as interesting to run. This was mostly to look at the patterns of how we access those two different approaches of a static design class and an instance design class. All right. So we're starting to see some patterns emerge here generally, but let's look at a very specific pattern now, and we're getting into some more common object-oriented terminology. And the first one I want to show you is a factory pattern. Now, remember back to that first example where I had a class attribute, and I was able to manipulate it directly. Well, we might not want that, that direct manipulation. We might not even want an external consumer of our class to even be able to directly create an instance of our class. And that's where we get into something called a factory pattern, where instead of directly using the constructor of a class through the new or create object syntax, we want to control the instantiation of our class. And what we do, as you see here, I've created a class, but the create is private, which means no other object can create an instance of my class except the class itself. So I've put the control of accessing the constructor back into the hands of my class itself. Now, I've still created a constructor. And in fact, I've very purposely put it here in the public section. And that's to demonstrate something here in a second. But I've added another class method. So I've created a static method in my class that is public that will be used to return an instance of this class itself. So instead of using the new syntax to create an instance of class in any calling program or calling class, they must call this factory method, and it will do the constructor and any other logic that we want as part of that instantiation, and it will then pass back an instance. And then I have an instance method here that isn't doing a whole lot. It's just returning the stored by stuff, which is a private attribute in my class, just so I can show you the scoping there. Now, I intentionally kept this very simple. There's not really much reason that I would use a factory method here because I'm not really doing anything in it except creating an instance of the class. But I did this on purpose to keep it super simple. And in our next couple of examples, I'll show you how we really put this factory method to use. And I see there was a question here about, will this work as a singleton? Hold on a second. The singleton pattern is the very next pattern that we're going to look at here in a second. But I wanted to introduce this concept of the factory first as a standalone pattern. And then we'll see in a minute how the factory pattern can be used in other patterns like the singleton and the composite pattern. All right, so what we have here, let's bring up the tester as well so we can have a look at this. So for this to work properly from the calling class, we don't use the new syntax, but we use the static method of the class to ask it to please instantiate itself and return an instance. And then once we have that instance, we use it like normal. So I've got an instance called factory instance, and I can output the private attribute by calling a method of that class. And I'll just go ahead and run it here. And there we are. You see the output coming out. Now, what's interesting here is if I uncomment this, what you see here is if I'm trying to create an instance, new instance, I get a syntax error. An instance of the class cannot be created outside the class because of this create private. Now, that's going to stop me from doing this. I get a syntax error here, right? But it might even have been better if I took the constructor and I made it private, and then it really wouldn't even be visible outside of my class. Let's see if that changes the error message. I'm trying to. Now you still get the same error message, but it just makes it a bit more obvious that the constructor is not intended to be called outside by not putting it in the public section. But it doesn't change the protection of it. The protection comes via the create private. As soon as I have that, it won't let me instantiate it. Wonder, I haven't. If I try that, yeah. And if I change that to create public, then I get a syntax error over here that says, you sure you know what you're doing? because you set the visibility to be private, but then you said create public. That doesn't make any sense. So it won't let you do a mismatch in that direction, because that wouldn't logically make any sense at all, right? So let me just set this back and activate. Question there. If the factory method is called twice, we should check if the instance is already created. Ooh, that's an excellent question, because that brings us to our very next topic, which is singleton patterns. Now, your question is valid, in that maybe is the right answer. Maybe you want to make sure that only one instance is ever returned in the factory method. Or maybe you just want to do some additional logic, but still return multiple instances as you would in any normal class pattern. And I'm actually going to show you both those examples next. I'm going to show you using a factory that returns a singleton meaning a single instance, no matter how many times it's attempted to be instantiated via the factory, and a composite pattern, which uses a factory to return instances, but that can return multiple instances because it's a facade for a database record once again. All right, so let's look at singleton. Now, I have to admit, singleton is a pattern that you can do in ABAP, but once again, going back to what we talked about earlier about like the lifetime of the static attributes, you have to remember the singleton, it's designed to return a single instance of a class, no matter how many times that instance is called, within the lifetime of the user session. So this is another one that is a little limited in its use case in the ABAP environment compared to other runtimes, because this is only within the scope of the user session. But this is the kind of thing that is often used. For instance, I want to read or write to a log. And no matter how many different, where I am in my calling program, I always want to get back to the same instance of my class so that I can read and write to a single instance of a log. Now, in ABAP, we could probably just about do this with a static class and a static attribute as well. But I wanted to demonstrate the singleton pattern, even though personally over the years I was trying to think of a time that I've used this and absolutely needed a singleton, and I couldn't really come up with one. You see this most often probably used in SAP provided reusable frameworks, where we need to make sure a single instance of our class, maybe because we're connecting to an external resource. You see this when there's external HTTP calls or something like that, and we need to get back to the same instance of that class to access something about it, right? So what we do in this, we continue with the factory approach. So, create private, we've got a class method with a factory. Once again, it's going to return an instance of the class. We've got a method to write to the log. We've got a method to read from the log. Now, what's different here is I'm keeping class data, a static attribute of that instance of the class. So what we're doing in the factory is we're looking, is there already an instantiated version of the class? Is there already an instance of the class? So if self is not bound, then we go ahead and create a new instance of the class. Otherwise, we return the existing instance of the class. And this way, even if we have multiple calls to the factory, to ask for an instance of the class, maybe in different parts of the calling program, they're always going to get connected to the same instance. And therefore, they're always going to have access to the same internal table, this log internal table, although it's not class data, it's not a static attribute, will live on, will not be garbage collected, because it's going to live within this instance of the class that's going to be perpetuated. And if we look at our Singleton tester, this is really pretty straightforward. I'm going to ask the factory to give me an instance of the logger. I'm going to write to the log, and then I'm going to read the log. And then I'm going to create a second instance. I'm going to request a second instance of the logger. And I'm going to write to it, and I'm going to read from it. And what we're going to see on the second read, it's going to have both records in it. Let's go ahead and run this. And what we see here is that on the second output, it's got both records, even though, as far as I'm concerned, I'm working with two different instances of the class. And even if I would come here and let's say I would clear the first instance, that's not going to matter. My second instance has still got the same, it's the same instance, because when you're doing this, when I'm clearing this, I'm just clearing the pointer to it, the reference to that class, but it's not being garbage collected. It's not being completely freed because there's still another reference to it here. As long as one reference to an instance of the class remains, the garbage collection will never occur. It will never completely delete it. Nice. Now, this is a little too simplistic of an example. It doesn't really show the power of this. The power would be in very different parts of the call stack. Very different in multiple classes in a class hierarchy are calling to the same logger. You're not having to pass an instance around, put it in in a global attribute, global memory, or anything like that. You can always get back to the same instance. You don't have to worry about persisting it. The Singleton pattern takes care of that for you. The question about why don't you use the unit test for testing? I don't use a unit test for testing because I'm just trying to demonstrate. My testers are not really tests in that I want, they're more demonstration. I want to be able to show you how a normal class would consume this and not necessarily go through a test pattern. That's why I chose to do that. Question: will we cover a facade pattern? No, not directly. I mean, I think in a way, the instance method is a facade for the database record. And other facade patterns, I thought about doing one for like an external HTTP call, but it really is just an encapsulation of the logic, which we sort of do so naturally. I didn't think that was one that needed to be called out so much in the ABAP world. Does ABAP take care of multi-threaded problems of a singleton class? Yes, because you don't have to worry about threading in ABAP. Your user session runs within a single dialog work process. And although there's multi-threading within the ABAP kernel, there's no multi-threading or asynchronous processing within the single ABAP runtime execution of a single class. So that's why we don't have to worry about synchronization or anything like that on a singleton pattern in the ABAP environment. Question about performance and being used multiple times in day-to-day operation. I guess that depends what you mean by multiple times. If like going back to my static and my instance example multiple times. I mean, if you're creating tens of thousands of instances of the class, you'd probably then want to look at optimization so that you're not repeating redundant SQL statements or something like that. It's really kind of too general to say based upon what multiple times in a day-to-day operation means. That can mean so many different things. Points to consider while using different patterns. Well, I think like we said, the Singleton pattern is often used in sort of when you have a framework approach, like a logger, where you need to get access to it at different points in the calling program, and you don't want to basically complicate the logic of the calling program to have to know that that is in fact a singleton. Let's go on to the final pattern that I want to cover this morning, which is the composite pattern. And I think you'll see another use case here is this pattern is very useful when you want to encapsulate logic and make it easier for the calling program to access different aspects of a business object. And I use that term generally, without having to understand those differences themselves. So what we have here is, I'm going to use the flight example again. So wait, before we're going, sure, there's multi-threading call functions starting new task. Technically, that's not multi-threading, because when you say starting new task, that's going to another dialogue, that's going to another work process. So not really threading, because threading would assume a single thread, or multiple threads in a single session. And when you go to another work process, you're actually opening a second session. And then, of course, in that case, it has its own role memory, and when you do that, starting new task, because you're in a completely different user session, like static attributes and things like that would not carry over into that new task. So new task is not multi-threading. So just jumping back here, composite pattern. We want to take the flight model. So everybody's probably familiar with that. If you've done any training, we have this flight database. We could read records out of the flight database, so different flights from different cities, but there's different plane types within there as well. We've got 747s, A340s, other types of planes. And maybe what we want is we want some logic to be very generic for all the different types of planes, but then maybe we want some logic to be specific to a particular type of plane. And we can do this and build it into a class so that our calling program doesn't have to know about those differences, but can be affected by them. So what we want to do here is we actually I'm going to start with a base class. But in this case, I've made it abstract. So you can't create an instance of this base class. It's just going to describe a flight in general. But then we're going to have more specific instances, because we want to create more specific types of classes for the different types of planes that we have. And what we're going to do here is we're going to use an interface to describe the things that are common for all different types of flights. They all have a cost. They all have a method to get the flight details. They all have a method to calculate the flight. The interface, the description of this attribute and these methods are the same for the different types of flights, the different types of planes, but the implementation can be completely different. And that's what we want to describe here, is in this base class, we're going to define the constructor. And we're going to have a factory method. And what we have here, the constructor is very simple, but the factory method is not so simple this time. So what we're going to do is we're going to take keys of the class that we have returned, and depending upon that, we're going to go ahead and read that record from the database. And depending upon the flight type, we're going to instantiate a different subclass. So if it's a 747, we're actually going to create an instance of a completely different class, the 747 class. Let's And if it's an A340, we're going to create a completely different instance, this A340, or any other plane type, we're going to create this other class type. We're going to go ahead and do the create object dynamically because we're deciding the target class dynamically based upon the data that we're reading from the database. And then we're returning that instance in the factory. So this is a good use and probably a more common use of the factory pattern in the ABAP language. And it's also a bit of the facade pattern because we're creating a facade for the database, the business object itself, but through this hierarchy of classes. The other thing that we're going to go ahead and implement here is to calculate flight price. So we're going to add a $100 surcharge, and we're going to return the currency, and the flight details. We're just going to return the instance that we the record that we read from the database. So this is the base implementation of these two methods. Now, if we look at the more specific classes, the 747, the A340, I'll look it up here in a second. What we have is that they inherit from the base class and that they are friends with the base class as well, because we have this create protected, and that gives us the ability for the child class to be able to access back to the parent. That's the global friends relationship here. What that allows us to do, in this case, only the 747 class has movies. So we're able to pack extra attributes into the class that are only available to this certain plane type. We're also able to do a redefinition. By default, we inherit the implementation of the methods from the base class, but we're able to come in and do this redefinition of the flight price and change the surcharge. So now we still call the original implementation, that's what super is, telling it to call the original implementation, but then we're adding on an additional $35 surcharge on this plane type. We're also able to override the constructor. That's because we have this global friends, and we still call the original constructor, but then because we added this home movie attribute, we're able to populate the initial movies that are available on this plane. If we look at the A340, the A340 doesn't have the movies, doesn't have the extra method. We actually added an extra method here too to get the in-flight movies. All it does is it does a redefinition of the flight price and has a different surcharge. So what we're seeing is we're adding logic, but our calling program doesn't need to know about that. It doesn't need to know that an A340 has a different surcharge from a 747. That's built into the class definition itself, and we're encapsulating all that inside the class logic and the class structure itself. And then finally, for all other classes, I've just got this other class, and it has nothing in it. It has no implementation at all, because it basically falls back to whatever the base class is. There's no redefinitions needed, so it's basically just empty. So let's look at how we would consume this construct with my little test. Again, actually, I'm just going to make this bigger so we can see it well. So with the tester, now you'd probably take input from the user or something like that. But what I'm going to do is I'm actually going to read all the records in the database. And I'm going to loop over all those records. And for every record that comes back from the database, I'm going to create an instance of my class. So I'm really using it as a facade, the class itself, to process each record in the database. When we're calling the factory method, so we're using the base class, we can't instantiate it directly. We're using the factory method, so the factory pattern. We pass in the keys of whichever record that we're on in our loop. And then without knowing anything about the flight type, the plane type, we just call the get flight details and the calculate flight price. And for each one of these, it's going to use the correct one for the plane type of the record that we have. It's going to use the right surcharge. So it's calling, this flight object is actually going to be a different object type for each pass here, but no dynamic logic in my calling program. It doesn't have to know about any of this. The only time that I need to know the specific type is when I want to call that specific method that only exists in 747. Remember, in 747, we added the in-flight movies and we added the extra in-flight movies method. I have the ability to go from my base class. So this flight object, all my calling program knows is that it's the base class. But I can check the plane type. And if it is a 747, then I can cast it into the more specific object type. So I'm saying cast this object into the 747 specific type. And then I can call the get in-flight movies, which only exist, it's a method only exists on this more specific class type. And I'll output the movies. And if we go ahead and run this, what we see here is a bunch of records, but only some of them have the movies, because only those are the 747s. And see, none of the other records are getting the movie titles. So we kind of have a lot of dynamic logic. We would also see, we set a breakpoint and went inside the method, which I'm a little out of time this morning. Otherwise, I had planned to set a breakpoint and go into the method to prove to you that it was getting a different surcharge. But if you study the data closely, you'll see that. But all that logic is just encapsulated into our class structure. My calling program doesn't need to know about any of that. And it only has to dip into the more specific class when I actually need it. And even then, the logic is very generic from the calling class. I'm just doing an if check and then only doing a cast if we pass that if check. So we see we pushed the responsibility for the logic and the differences in the different business object types, in this case, plane types. But you can imagine you could do this different order types, for instance. Sales orders, purchase orders, different order types need different logic. You could encapsulate that into different subclass objects and remove that logic and responsibility from the calling program from having to know about Good question about the demo code. Actually, I have a I have a GitHub repo that has some object-oriented basics in it. This afternoon, I will add all the code from this from these new classes that I just created to that existing GitHub repo, and I'll put a link into the description in the YouTube video. So you'll be able to get that a little bit later today. I'll push that all out there. Yeah, can we make the base class abstract? The base class is abstract. There was a question, could we make the base class abstract? The base class is abstract. And that's an important part of what we're doing here. Nobody can instantiate the this class directly because it is an abstract class. Question, I thought this was the strategy pattern. I don't think I've ever seen it called the strategy pattern, but that is part of the thing about OO patterns. It isn't like there's a hard and fast rule about the naming. I mean, you'll see different descriptions of these patterns. I mean, it's a logical construct. I've always seen this called the composite pattern, but that's that's terminology, right? That isn't like you go and there's something in the syntax called composite or something called strategy. So sometimes different texts, different academic descriptions of things will describe them differently. I have always heard this referred to as the composite pattern, however. Is instance of could work as well instead of CS name. I'm not sure what that's referring to. Is that, oh, instead of the contain string, is instance of, that might work. I don't know if I've ever tried that. To me, it's cleaner readability this way, as you're checking the plain type. And I had to do contain string simply because there were variations of 747. There's the sub type, and we only wanted, just to keep the example simpler, I only wanted to check on the first part of the plain type and not have to deal with all the sub plain types. So that's why I did a contain string instead of an equals. I don't know, I have to try that with the is instance of, but I kind of feel like checking the plain type directly, the value of the plain type, is more readable logic. Is it really in need of the friendship? You need the friendship because the 747 redefines the constructor to add the initialization of its own attribute, the movies. And because we want to redefine the constructor, we have to and call the super, call the base constructor, and then redefine it. In order to call the super, that's why we need the friendship there. The object lives on a heap, like in Java. Same concepts are different. Yeah, actually, I mean, you don't get a lot of, we don't talk about heap versus stack that much in ABAP. Most of that's taken care of for us, but the object does live in the heap. I don't know if that, I don't know if that has a lot of bearing on much of anything in the ABAP world anymore. Like I said, the ABAP runtime takes care of those things for you. Rarely, if ever, have I ever been impacted by that. But yeah, to answer that question, is how was it created by the factory method? How was it created by the factory method? I'm not sure what you mean there. I mean, we have the factory method in the base, right? So we have a factory method. It's doing the select from the database based upon the keys. and then it uses the data and looks at the data that was returned and looks at the plane type there, and then it does the create object and returns it. So this is a case where the factory method is particularly important to this pattern, because we wouldn't want to expose this complex logic for the creation of the subclasses to the outside world. We want to encapsulate that into the class itself. All right. I think that's all the questions, and we are a little bit over time. I wanted to go ahead and keep running there to answer those additional questions. I hope you found this interesting, this introductory look to patterns. There are many more patterns out there. Like I said, I picked a few that I thought were the most useful in the ABAP environment, particularly when you are writing your own classes. That's not to say that there aren't other patterns out there that are useful. Actually, in my original list, I had wanted to actually show unit test and dependency injection patterns, and just sort of dropped it, partially because of time and partially because that could be like a whole separate session of itself. Because getting into unit testing and to the question earlier, why didn't I use unit test? I kind of wanted to not overload the session with too many different concepts. That's no detriment against that other concept, but I just think it deserves maybe a topic of its own. So there's certainly other patterns out there, but maybe maybe this helps you get a little bit more comfortable with object-oriented concepts in the ABAP environment in general, shows you the power and the usability of some of these patterns. Yeah, I hope you enjoyed today's session. Great kickoff to Devtoberfest. Thanks for so many people joining this morning, and everybody have a great day. And we'll see you for more Devtoberfest sessions not too long from now.